Okay, so now we are going to talk about resistances. And when we talk about resistance, technically speaking, resistance is what? It's the opposition. What is resistance? It's the opposition. Who does this opposition? The conductor. Who do this opposition? The conductor. So resistance is the opposition of a conductor. Resistance is the opposition of a conductor. What does it oppose? It opposes the flow. It opposes the flow of electric current. So resistance is the opposition of a conductor. Resistance is the opposition of a conductor. To do what? To oppose the flow of electric current. Now you might be thinking, why do we need to oppose the electric current? Why do we need to limit the electron flow? See, when I do not limit the electron flow, if I have no resistance in my circuit, that means the current will flow in uncontrolled way. There would be a huge current, and the more the current, it means the more would be the heating of the wires. More the current, more would be the heating of the wires, right? That would result in short circuits, electric fires, and whatnot, right?
Yes, sir.
So in order to limit our current, in order to make our circuits work properly, what do we use? We use the resistors. We use resistor. So resistance is the opposition of a conductor to the flow of electric current, or more formally I can say it controls the flow of current. Controls the flow of current, right? Now that is one concept of resistance. Whenever examiner asks us to define what is meant by resistance or what is resistance, right? So basically you would explain it this way. It is the ratio of potential difference and current. What is resistance? It's the ratio of potential difference and current. What is resistance? Ratio of potential difference and current, right? So that means my formula for resistance would be R is equals to V upon I. R is equals to V upon I. Got it?
Yes.
And then moving further. So this is my formula for resistance. Now resistance is again a physical quantity, and for every physical quantity we must know its unit. We must know its unit. So the unit of resistance is ohms, and it can be measured using an ohm meter. It can be measured using an ohm meter, right? And then if I talk about resistors, there are two types of resistors. A resistor might be a fixed resistor, or it can be a variable resistor. Fixed resistor or variable resistor. A resistance whose value you can vary as per your need, right? Variable resistor. Fixed resistor. Got it?
Yes.
The difference between the two is one is just a rectangle with two lines at the ends. The other one is the same diagram but with an arrow in the mid. That's the difference between thermistor and resistor, right?
Yes.
Okay. So I have talked about the two types of resistances, and then if I need to if I need to find the resistance, I will be needing the value of voltage and the value of current, right? So if it is a fixed resistor, if my resistor is fixed resistor, that means no matter whatever the current is, whatever the voltage is, resistance of the resistor will stay the same. It will not change. Resistance of the resistor will stay the same. It will not change, right?
Yes, sir.
While if it's a variable resistor, that means you can alter the resistance of the variable resistor as per your need. At times it might be larger, at other times it might be smaller. Alright?
Yes, sir.
Alright. So then when we talk about the value of a variable resistor, yes, I told you that the value of the variable resistor can be changed. The value of the variable resistor can be changed, right? So if you look over here, there's this question. A 30 coulomb of electric charge. How much charge? 30 coulomb.
30.
Flows past a point in a wire in 2 minutes. What is the time? 2 minutes. Whenever you find the word minutes in your question, just put a multiplied by 60. Just put a multiplied by 60. So it's 2 minutes means 2 multiplied by 60. 2 multiplied by 60. That means 120 seconds. What is the time? Time is 120 seconds, right? So I know the time.
Yes.
I know the time, and I know the charge. So what is the current? Current is charge upon time. What is current? Current is charge upon time. Alright,
Yes, sir.
charge upon time. So please, would you let me know the value? Alright, so that would be 120. That's the charge. 2 into 60. This is 120 upon time. Time is how much? Sorry, my bad. It's 120 is the time, and charge is 30, right? So 300, 3 ones are 3 fours. So 1 upon 4, that's 0.25 amperes. 0.25 amperes, right? Okay, that's done. Then here's the next question. A current in lamp is 0.2 amperes. A current in lamp is 0.2 amperes. If the lamp is switched on for 2 hours, what is the total electric charge passing through the lamp? So charge is what? Charge is equals to current into time. Charge is equals to current into time, right?
Done.
So what is current? Current is 0.2. What is current? 0.22. And what is time? 2 hours. So 2 times 3600. 2 times 3600, right? So please tell me the answer.
Let me get my calculator.
Please always keep it along with you. So yes, what do you say? 1000? 1000?
1440.
1440. 1440. 1440, right?
Yes, sir.
So we know the charge now. We know the charge now.
No? Yeah.
Alright, and what's the unit of charge? Coulombs. What's the unit of charge?
Coulomb.
Alright, I would want you to do the last question yourself.
240 years.
Alright. Okay, so here it's asking about the potential difference. And potential difference, I told you, it's the work done upon charge or energy upon charge, right? So the work done or the energy given to you is 9 megajoules, and mega means 10 to the power 6. So you need to convert that. That means you would say 9 into 10 to the power 6. 9 into 10 to the power 6, right? Upon charge, what's the value of charge? It's 3.75. 3.75 exponent 14 coulombs, right? So V comes up to be something around 240 volts.
Yes, sir.
Alright, good. Got it? Any problem, any confusion?
No, sir.
No, good. Alright, so we'll move on. And the next thing up is an experiment to determine the resistance, right? So we'll do an experiment in which we can find the resistance, of an unknown resistor. But before we move on, we need to do resistor coding. See, in our syllabus, we are only concerned about the first 3 bands. See, there are 3 bands. How many bands? 3 bands, right? And each of the band will represent a specific value. Like the first band would represent first digit. Second band would tell you the second digit, and third band would tell you the number of zeros. Right? It will tell you number of zeros. Okay, so that means with the different colors of the band, I can make a resistor of different value. So let's say, first of all, talk about these only colors available on this band. What is the first color?
First color is brown.
Brown. So what is the number of brown?
1.
1. So that means my first digit is 1. Okay, what is the second band?
Black, so 0.
So my second digit is 0. So that means first band represents first digit of the value, second band represents second digit of the value, right?
Yes.
And the third band will tell you how many zeros you need to put in. How many zeros you need to put in, right? So what is the third band? It's blue, red, sorry. So how many zeros do I need to add?
2 0.
2 zeros. So what is the resistance of this resistor? 1000 ohms, right?
Yes, sir.
Tell me any three colors of your choice.
So, yellow, green, and red.
Yellow, green and red, right? So first band is yellow, that means the first digit is 4. Second band is green, so the second digit is 5. Third band is red, so how many zeros?
2 0.
So 4500 ohms, right?
Yes.
Okay.
So, have we memorized it?
Not at all. These colors will be given to you if a question comes on this, right?
Okay.
Okay, tell me any other value, any other combination of colors.
Purple, white, and black.
Purple, we call this violet, not purple. All right, violet. Okay, violet,
White and black.
white, and black. Right. All right. So that means the first digit would be
7,
7. Second digit would be
9,
9, and the third digit would be
0.
no,
No zeros.
no zeros. So my resistance is 79 ohms. Do you get this?
Yes, sir.
Tell me any last choice of colors.
Brown, gray, and
Brown, gray, and
blue.
blue. Okay, so that means the first digit brown, first digit is 1, right? Second digit is
8.
8, and the third
So, 6 zeros.
6 zeros. 1 2 3 1 2 3, right? So 18,000 ohms, right? This is called the resistor coding. This is called the resistor coding. Understood?
Yes, sir.
All right.